All right, this is the Unit 11 Test Study Guide. Topic 1 is Fundamental Counting Principle, Permutations, and Combinations. I was accidentally recording for a while while my iPad was out of storage. Or I thought I was recording, I was just talking. So I have some of these written down already. So number 1, 10 questions on Jack's science quiz, 6 multiple choice questions with 4 choices, 4 true and false. So all 10 questions, there would be 10 things multiplied out, but the first 6 have 4 options. So you've got 4 choices times 4 choices, etc. for all 6 of the first questions. That's the first part. Times 2 options for the next 4 questions, so that's this. So when these get multiplied all out, we end up with 65,536. This is another counting principle one, except we're kind of working our way backwards. So we have combo meals with a sandwich, a side, and a drink. So we know that there are 560 combos available, so that's the right-hand side. There are 16 sandwiches, a certain number of sides, and 5 drinks. So this is like solving an equation when it comes down to it. So 16 times 5 is 80. 80 times however many sides there are gives us 560 combos. And so what you do to solve for the number of sides is you would divide both sides by 80. So 560 divided by 80 is the same as 56 divided by 8, and that would be 7. All right, next one here. Marlena must answer 3 out of 8 essay questions. So this section, 3 through 8, you have to first choose if it's a permutation or a combination. That way you know if order is necessary, which formula you would use. So we are not looking at order for this first one because it's just answering 3 out of the 8. It doesn't matter what order they're in. So I'm going to plug in. I'm going to use Desmos for this video. So this one, we have a combination for sure because order doesn't matter. There are 8 essay questions and she's choosing 3. So on Desmos, you have the combination here and you would have 8 choose 3 like that. So you end up with 56 options for that one. Number 4, the Grandview High School Band plans to play 6 pieces of music in their upcoming concert. How many ways can they arrange the order? So order matters. It's a P for permutation, and they're using all 6 pieces of music. So 6 choose 6. Remember, this is a little shortcut that we had in the notes that if you're using all of them, so like n choose n for a permutation is just n factorial. So 6 factorial. We have 6, and then in that same functions menu, there's a little n factorial button. So that comes out to be 720. All right, next ones. I made it pretty far before I realized it wasn't recording. How many ways can president, vice president, and treasurer? So when you have different assignments like that, it's definitely a permutation because it matters which person is in which position. So there are 40 students, and we are selecting 3 different officer positions. So again, in Desmos, this time the function we use is the P for permutation, and 40 choose 3. So that ends up being 59,280. Next one, number 6, Josh must submit 4 of his 25 paintings as part of his application to art school. When you're submitting paintings, the order does not matter. So this is a combination. He's got 25 of them, and he wants to pick 4. So this one is, combination, we want 25, choose 4. So we've got 12,650. All right, so we started in on number 12, and this is actually incorrect because I was not paying attention to repeats. Because remember, permutations, every once in a while you have a repeat. So even though the order does matter, you could potentially have a repeat if you have repeat letters. So we want 12 letter arrangements can be made using the letters in the word carelessness. So look for the repeats. So we have E's, we have 3 of them. And then we have S's. We have 4 of those. So we have all these repeat letters. So unique letters, we have 1, 2, 3, 4, 5, 6, 7. So there are 7 unique letters and a bunch of repeats in there. So we want 12 letter arrangements. Okay, so think if we want to take 12 things total. So you would have 12 factorial in the numerator. And then what you do when you divide is it's like you're dividing out the different ways that you could permute those repeats. Okay, so we have 1, 2, 3 E's. So you divide by 3 factorial, because that's all the different ways that you could rearrange those 3 E's, because it'd be like the first E, then the second E, then the third E, or the second E, then the first E, and the third E. And since that wouldn't make it different, you divide those options out. And then the S's, I guess I can uncover this. The S's, you have 1, 2, 3, 4. So again, all the different ways that you could rearrange those 4 letters that wouldn't actually come out any differently, you would have 4 factorial like that. Okay, so let's plug this in. So you have 12 factorial divided by 3 factorial times 4 factorial. So this, we still end up with a whole lot of options here. So 3,326,400. So still quite a few ways, even dividing out all of the repeat answers. All right, number 8, field hockey coach chooses players to put away equipment after each practice. If there are 16 players, how many ways can she choose? 5. So in this scenario, order definitely doesn't matter. There are 16 players and we are choosing 5 of those players. All right, so combination, we've got 16, choose 5. So 4,368. All right, so on to topic number 2. We've got some different probability stuff and independent versus dependent events. So our first one right here, Kate is randomly choosing a date in the month of August. What's the probability that she chooses a 2-digit number or a prime number? Okay, so you've got 2 separate things. You'd end up adding that probability together, or you could just kind of add them together in your own head. So August has 31 days. That is all the possible total outcomes. 2-digit number would be anything but the first 9. So a 2-digit number, you would have 22 options for that. And then you would want to figure out, so I'm going to write everything down. So 22. And then how many of the single-digit numbers are prime? So that would be 1, 2, 3, 5, or 7. Okay, so you've got an additional 4 options there. 1, 2, 3, 5. Oh, think that through. Yeah, 5 more options. Okay, so this would be 27 out of 31. All right, Eric is randomly choosing a card from a standard deck. What's the probability that he chooses a card that is red and a multiple of 3? Okay, so randomly choosing a card from a deck, that is 52. A multiple of 3, so think through those options. So you've got 3, 6, 9, there is no 12. So you've got 3 of them, and then you double that because there's the diamonds and the hearts. So there would be 6 total. And 6 over 52, those are both even, so you can reduce those down to 3 out of 26. All right, number 11, one of the 50 states is chosen at random. So we've got 50 states. And then what is the probability of not choosing a state? So that's one of those where you do 1 minus and then whatever you're looking at. So a state that begins with the letter N. Okay, so this is something that you might want to do some Googling for. But you've got North Carolina, North Dakota, Nebraska. I'm actually going to pull up. Let's look for a list of states here. So things like this, we wouldn't have exact. So let's see what I can Google. States beginning with N. Let's see. We've got these ones. 1, 2, 3, 4, 5, 6, 7, 8. All right, so there are 8 of them out of 50. So you subtract that 50 of 50 and then minus 8. So you end up with 42 of the 50 don't start with the letter N, and you can cut those in half to get 21 out of 25. Number 12, Tony's wallet contains 6 $1 bills, 4 5s, 2 10s, and 3 20s. If Tony randomly removes a bill, what's the probability that it is at least $5? Okay, so we've got 6 plus 4 is 10, plus 2 is 12, plus 3 is 15. So he's got 15 bills, at least 5. So 4 plus 2 plus 3. So that would be 9 of the options are at least $5. Or thinking 6 of them aren't, so you could subtract 15 minus 6. And this reduces by 3 to 3 over 5. Okay, so that's your first page. We've got more of this topic on the next page. Okay, so number 13. A number 1 through 3 is randomly selected, followed by a letter from the word targets. What's the probability of choosing a perfect square, then the letter T? Okay, so now we're moving on to some of these compound events here. So what is the probability of choosing a perfect square? So out of these 30 numbers, we've got 1, 4, 9, 16, or 25. So that's 5 of the options are perfect squares. Times, and then a letter from the word target. Choosing the letter T would be the first or the last, so that's 2 out of the 6 letters. And if you want, you could reduce these down before you multiply. So this is, 5 over 30 is 1 in 6, and then this is 1 in 3. So when you multiply these out, you get 1 in 18. All right, number 14, Carter's handing out Valentine's Day cards to his friends. He has 8 Batman, 12 Superman, 5 Captain America. What's the probability that the first 2 he chooses are Batman? Okay, so this is going to be a scenario without replacement, because he gives one to his friend, it's gone. He now only has 24 total. So he's got 8 and 12 and 5. So that's 25 total. 2 Batman in a row. So initially you have 8 out of 25 are Batman. Then once one of them is gone, only 24 cards remain, and only 7 of them are Batman. So multiply these out. The numerator, 8 times 7. Actually, let's reduce first. 8 and 24, you can reduce to 1 and 3. So now multiply out 1 times 7 and 25 times 3, 75. Okay, questions 15 and 16. A bag has 25 red chips, 18 blue, and 29 yellow. So when you add those together, that ends up being 75. So we have 75 total. Chip is selected and replaced. That's important. All right, so a chip is selected and replaced. So every time you're working with 72 total. So 72, blue, then red. So 18 out of 72. Then you put it back. You've still got 72. And then red would be 25 of the 72. All right, so let's reduce these down. So 18 and 72 is 1 in 4. So multiply 1 times 25, and then 4 times 72 is 288. All right, next, 16, again with replacement, yellow, then blue. So yellow would be 29 of the 72. Then it's replaced, so you still have 72, and blue would be 18 of the 72. So again, this reduces down to 1 over 4. So 29 times 1. And 72 times 4, same value as before. So just a slightly higher probability than this previous one. All right, 17 and 18, we've got a box of pizza with, it's a weird box of pizza. The slice is eaten, and then he chooses another. So that means there is no replacement, obviously. So we've got 3, 10, 15 slices. So the probability of choosing cheese first would be 3 out of the total 15. Then one of them is removed and eaten, so it goes down to 14 total. Then supreme. There are still 5 supreme slices because the first one was cheese. So this is 5. All right, so the 3 over 15 we can reduce down to 1 over 5, and then actually the 5s would end up canceling. So this reduces down just to 1 over 14. Number 18, 2 pepperonis. All right, so at first you've got 15 slices and 7 of them are pepperoni. Then after 1 is removed, you have 14 slices and only 6 of them are pepperoni because you did remove 1 of the 7. All right, so let's reduce. So 7 and 14 reduces down to 1 over 2. 6 and 15 reduces to 2 over 5. And the 2's cancel. So this ends up being a 1 in 5 chance of getting 2 pepperonis in a row. All right, third topic, conditional probability. Okay, so this is something happening given that you already know that something else happened. All right, so number 19. Mason randomly chooses a card from a standard deck of playing cards. What is the probability that it is not an ace given it is a red card? Okay, so cards before we were dealing with 52, but given that it is a red card, means that there are only 26 out of 52 that are red cards. What's the probability that it is not an ace? So 2 of them are aces out of the 26, which means 24 of them are not. Okay, and you can reduce those by half, so that is a 12 in 13 chance that it is not an ace. Number 20, 1 of the 50 United States is randomly selected. What is the probability that it has 2 syllables, given it starts with the letter M? All right, so let's have some fun here again. We're going to get a list of the 50 states. Okay, so given it starts with the letter M, so let's take a look at this list here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So given that it starts with the letter M, we know that our denominator is going to be 8. And then the probability has 2 syllables. 1, 3, 4, 3. None of those have 2 syllables. So 0. There's a 0% chance of getting a 2-syllable state that starts with the letter M. There are not any. Number 21. This is one where a Venn diagram might be a good scenario. Of the 318 sophomores, 140 are taking Algebra 2 and 102 are taking Chemistry. 26 are taking both. If a sophomore, that's spelled wrong, is chosen at random, find the probability that they are taking Algebra 2 if it is known they do not take Chemistry. Okay, so we're going to do a little subtraction here. So if it is known they do not take Chemistry, 318 minus 102, so 216, that's how many do not take Chemistry. So that's going to be the denominator. Okay, find the probability they are taking Algebra 2. So 140 are taking Algebra 2. 26 of them are taking Chemistry. So that would again just be a little subtraction. So 140 taking Algebra minus the 26 that we know are taking Chemistry. So that would be 114. Okay, so let's see. These are divisible by 6. So this divides down by 6, and then 114 divided by 6 is 19. So you always want reduced fractions for these probability questions. Number 22, a group of cell phone owners was asked whether they had an Android or an Apple, and then we have male and female in this category. So probability of a male that owns an Android. Let's get some category totals here. So 34 plus 60 is 64 males. 19 plus 42 is 61 females. 34 plus 19 is 53 Android. And 30 plus 42 is 72 Apple. So just to get some totals. And so then the grand total, either 53 plus 72 or 64 plus 61. There are 125 totals. That will help when you're answering. So probability of a male that owns an Android. Okay, so that is just this category right here out of the grand total of 125. So there's no conditional probability yet. So the denominator is just all of them. And this is both Android and male. Okay, and that's 34 is divisible by 2 and 17. So this does not reduce down. All right, it's probability of an Apple phone given that the person is a male. Okay, so there are 64 males that were surveyed, and then the Apple is 30 out of those 64. Okay, so 30 and 64 are both divisible by 2, so you can reduce that down to this. Okay, and then probability that the person is a female given that you know they own an Android. Okay, so the total of people that own an Android would be 53, so given that you're already in that category, the probability of being a female would be 19 of those people. And 19 is prime, so that is as reduced as that one will get. Okay, we've got a couple more of this topic on the next page. We have one of these tables that we're going to be making. All right, so the table shows the number of gold, silver, bronze medals by the U.S. and China during the 2012 Summer Olympics. So we want the joint relative and marginal relative frequencies. All right, so let's look at grand total here. We can even do some category totals. So gold, 46 plus 38, so there are 84 gold. 28 plus 28, whoops, is the silver. And 29 plus 22 is the bronze. Let's see, US is 103. And China is 88. So add those together. We've got a grand total of 191. Okay, so we can get all of those different values. So we have the first category is 46 out of the 46 out of the 191. So we want 4 decimal places here. So 0.2408. Next, China is 38, or China in gold is 38 out of 191. So that is 0.19, and then that would round up to 90. Then we'll do the total, so that's 84 of 191. Okay, 28 silver US out of 191. So it's 0.1466 would round up. 28 silver in China out of 191. 0.14, oh, same one. And then the total is 56 out of the total. So 0.2932. Bronze, got 29 of 191. So these are all just dividing these numbers by 191. So 0.1518. Next box, 22 of 191. 0.1152 would round up. Total is 51 of 191. 0.2670. In our last category, these totals, 103 for the US out of 191 is 0.5393. China had 88 of the 191, so that's 0.4607. And then, of course, these all together would be 1. That last box should always be a 1. So all of these here. If a metal from those above is randomly selected, find each probability. So the probability of a US bronze metal. So these ones, without the condition, you're just literally pulling it off the table. Okay, so US bronze metal is this right here. So 0.1518 is 15.18%. Probability of a gold or silver metal, those ones would get added together. Okay, so a gold or silver metal. Gold is this one right here, so 0.4398 plus a silver metal is 0.2932. You could also subtract the bronze from the total if you wanted to. So we add those together, we get 0.4398 plus. We get 0.733, so that would be 73.3%. Again, another valid way would just be to subtract the bronze total. All right, probability of getting a silver given that it's one of the Chinese metals. Okay, so the silver, the denominator here is going to be the total for China. And then the numerator will be the silver within that category. So 0.1466. So only the metals for China become your new total. And then we can divide this out. So 0.1466 divided by 0.4607. We get 0.3182, which would be 31.82%. Next, US, given that it's a gold metal. So if you reduce yourself just down to the gold metal category, that would be this total. So 0.4398 is the new denominator rather than all 100%. And then the probability of US in that category would be this. So 0.2408. So we do that division, 0.2408 divided by 0.4398. So that is 0.5475, so 54.75% for part D. Part E, China given that it's not silver. Okay, so here's what we're going to do for that. For not silver, we're going to add the bronze and the gold, or we could subtract 1 minus what the silver is, the 0.32. Okay, so not silver is 0.67068. Again, you would get the same thing from adding the gold and the bronze. Probability of China getting the metal. Okay, so not silver, like this is the silver one. So that one, it doesn't work by subtraction, or you could subtract it from this total, but this one's probably easier to add the gold and the silver under China. So 0.1990 plus 0.1152. So that would be 0.3142. And we want to divide that by 0.7068. So here we get 0.4445. So that would be 44.45%. Okay, and one more of these. Probability of a bronze metal given that it's not China. Okay, so not China would mean US. So this denominator would be the US total, which is 0.5393. And then the bronze just within this one column is 0.1518. So one more of these divided by 0.1393. Okay, so we get 0.2815. So that would be 28.15%. Okay, so on to the next topic. This is the binomial probability and binomial theorem. So we've got these ones where you have a number of different repetitions, the probability of success, the probability of failure. So we want to write all those things down. So for these first four, we have the exact same scenario. So there are prizes on the inside of bottle caps with a 3 in 5 chance of winning. So with each of these, I'm actually going to write this down. Probability of success is a 3 in 5 chance, which means the probability of failure is a 2 in 5 chance. And then there's a 12-pack of soda. So that's the value for n. So for n would be 12. So these three values are going to be the exact same for all four of these down here. Okay, so we've got a couple of exactly and then a couple where you'd be adding up some different totals. So exactly 2 prizes. Okay, so the coefficient is n, choose however many you want, which here would be 2, times the probability of success for how many times you want it, and then the probability of failure for how many times, I guess not want it, you probably want a prize, but this would be how many, and then how many are not. Okay, so that lovely value for this, I'm going to go into Desmo so that we're not trying to do this just on the phone calculator. All right, still got a bunch of stuff up here from the first page. All right, so our combinations, we have to start 12 choose 2, and then we're going to multiply that by 3/5 to the second. And then we're going to multiply that by 2/5 to the 10th. Oops, I squared it. 10th. There we go. Okay, so very small, 0.0025. So that is unlikely. That is a 0.25% chance. Okay, exactly 5 prizes. So this time the 2s are just going to be replaced with 5. So 12 choose 5. So probability of success to the 5th power, and then probability of failure to the remainder power. So we can set that up. And this one I'm actually just going to change a couple values here. So change that to 7, change that to 5, and then change this to 5. Okay, so 0.1009. So that would be a 10.09% chance. So a little bit higher there. Number 26, at least 10 prizes. So that would be 10, 11, and 12 all combined up. So we would take each one of these pieces. So 10, oops, let's see. So success to the 10th power, failure to the 2, and then combined with 11, so success to the 11th power, failure to the 1st power, plus, and then the 12. So 3/5 to the 12th power, and then 2/5, there is no probability of failure for that one. Okay, so all of these added together, I have plugged this in already. I'm just going to leave you guys to trust me that I've plugged it in correctly. What you get when you sub this all in is 0.0835. Okay, so that when you turn it back into a percentage would be 8.35%. Okay, and then this one's very similar. No more than 3 would be 3, 2, 1, or 0. So very similar setup. So for 3, you've got success to the 3rd, failure to the 9th, 12 minus 3, plus, then 2, success to the 2nd, failure to the 12 minus 2, plus, and then 1, success to the 1st, failure to the 12 minus 1, and finally, none would be success to the 0 times failure to the 12 minus 0. So again, I have this answer written down already. I'm just going to have you guys trust me that you know how to plug this in and I know how to plug this in, we end up with 0.0153 when all of those are added together. So small percent chance, since the odds are pretty good at winning. Okay, so about 1.53% chance. All right, so our next page, we're doing binomial theorem. All right, so this one we have quite an expansion here. So this one, the 9th degree. So each one of these terms, we start with the coefficient starting with 9 choose 0 all the way up to 9 choose 9. And then the a starts at the 9th power. The -2 starts at the 0 power. And every time you go, a's power decreases by 1, -2 increases by 1. Okay, so we first have 9 choose 0, a to the 9th, and then -2 to the 0. That'll be the first term. Plus, and then this pattern just repeats itself, doing exactly what I said. This goes 1, 2, 3, and keeps increasing. A to the 9th decreases to 8, 7, all the way down to 0. -2's exponent increases all the way up to 9. Okay, so we're going to have a bunch of different terms for this. So then the first term, a decreases, -2 increases. Then the second term, a decreases, -2 increases. Term 3, a decreases, -2 increases. Term 4, notice it's not the actual fourth term, I'm saying term 4, this is technically term 0. A decreases, -2 increases. Term 5, a decreases, -2 increases. Plus term 6, a decreases, -2 increases. Plus, oops, switch those, sorry, 9. C, term 7, a decreases, -2 increases. Term 8, a decreases, -2 increases. And one more, term 9, a decreases, -2 increases. Okay, so I want the process written out. You guys are going to have to trust me on whether I plug this all in correctly. So for 9 choose 0, then that gets multiplied by -2 to the 0. So our coefficient still just ends up being a 1, because this is a 1 and this is a 1. So we just have a to the 9th for our first term, plus, and then we have -2 to the first, which ends up being a -2, and then this ends up being a 9. So we have actually a -18, a to the 8th. Next term, 9 choose 2 multiplied by what turns out to be 4. We get a +144, a to the 7th. Next term, since this is an odd power, this ends up being minus, and this is a -8 multiplied by this. So these, you would just be plugging all these values into your calculator. You end up with 672, a to the 6th. Next one is positive, so this is this term right here. This times this ends up being this value times a to the 5th, minus this term, 4032 times a to the 4th. Now normally you kind of reach a peak and then they go back down, but that's without a term like this. This term makes it keep increasing and increasing. This one right here is a +5376, a to the 3rd. I gotta sneak the rest of these in here. This term ends up being a -4608. So sorry, -4608, a to the 2nd. Now we're down to this term right here. 9 choose 8. That's just 1, but then multiplied by -2 to the 8. So we get plus, oh sorry, 9 choose 8 is not 1, I lied. 9 choose 0 is 1, minus, so 9 choose 9 is 1, and then -2 to the 9th is 512, and we are done with the a's. So this beautiful term altogether is our binomial expansion. So 9th power is quite a process. 29, we have just the 5th power, so that'll be less of a process. So the process works exactly the same. We start with 5 choose 0, because 5 is the total degree, and then each one of these terms, so 4k starts with the 5th power, 1 starts with the 0 power. This increases until you hit 5. This decreases until you hit 0. this increases until you hit 5. So it works like that every time. So 5 choose 1, 4k to the 4th times 1 to the 1st, plus 5 choose 2, 4k to the 3rd times 1 to the 2nd. So obviously that 1 isn't going to do anything. 5 choose 3 times 4k to the 2nd times 1 to the 3rd, plus 5 choose 4, 4k to the 1st times 1 to the 4th, plus 5 choose 5, 4k to the 0, which will be gone, and 1 to the 5th. All right, so many terms there. This one, 5 choose 0 is 1, 4k to the 5th. Remember, you have to raise 4 to the 5th power as well. It's 1024, k to the 5th, and then just times the 1. Plus 5 choose 1 is 5, and then 4 to the 4th power is 256. So we end up with 1280, k to the 4th times 1. Plus, we have 5 choose 2, 4 to the 3rd, k to the 3rd. So you multiply those together. We end up at 640. 5 choose 2 is 10, and then 4 to the 3rd is 64 times k to the 3rd. Plus, next one, this obviously is 16. 5 choose 3 is 10 again, because remember, it's that binomial pattern. So this is 16 times 10, k squared, plus 5 choose 4. We end up just with 5 there, times 4 to the 1st is 20k, plus 5 choose 5 is 1. This is 1, this is 1. So our last term is just a 1. So all of these, you would have a calculator for all of these. So I'm just doing this like, hey, trust me that I actually plug these in and know what these values are. All right, next topic. We've got some stat stuff, measures of variation, normal distributions, and z-scores. All right, so number 30. So we have 10 field goal attempts made by the kicker. So with these ones, we want to figure out what the mean is, and just mentally knowing that, we can figure out what all of these values are. So the mean is taking all of these values and then dividing them by 10. So let me show you guys what this looks like on Desmos. All right, so next one right here. So in our functions, we have the stats category, and stats has the MAD. Remember, the standard deviation has to be done using that one that ends with a P. So the MAD, we'll type in our data. So we have 54, 29, 33, 62, 45, 39, 41, 52, 59, and 36. Okay, so that ends up being 9.4. Okay, so remember what that's doing is it's taking the average, the distance from the mean, and then just dividing that by the number. So it takes each one's distance from the mean and then divides the whole thing by 10. So speaking of which, let's get the actual mean so we can have that written down. Okay, so the mean of these whole values is 45. Okay, so when we want that, just kind of knowing what that is. So the way this is calculated is taking the absolute value of this distance plus this, all of these distances divided by 10. That's what this stat is. We are going to start with this guy first and then square it to get the variance. All right, so this, remember we want our standard deviation with the P on the end. That's going to slightly change our value. So that is 10.71. So what we do for the variance is we take that 10.71 and we square it. So we get 114.70, or just 0.7 if you want. All right, so that's our first set of data. Second set, number 31, we have Carl's last 8 quiz grades in Algebra 2. So let's figure out this mean. So this is out of 8. So next line, let's get the mean. Remember, if you know what the commands are, you can just type them if you want to. So the mean of 72, 93, 52, 86. Carl, you're kind of all over the place. Okay, so the mean is a 78. Okay, so remember with the MAD, it's taking the absolute value of this distance plus the absolute value of this distance all the way through the end, dividing that whole thing by 8. All right, so we're going to get, since we already have this data typed in already, you can just scroll your way over to the end. Okay, so this, instead of the mean, we want the MAD. So the average distance is 12.25. Okay, and then we can change our command to the standard deviation with the P on the end. And that would be 14.93. Okay, and then for the variance, we would take that 14.93 and we can square it. So 222.90. Okay, so just a lot of calculator practice with some of that, the measures of variation stuff. All right, normal distribution curve. So we've got 32 total recruits, has a mean of 27 with a standard deviation of 2. All right, so go up 2 and then go down 2. Okay, and then remember the way this spread works. We have 34.1 to each side for a total of 68.2 within the first standard deviation, then an additional 13.6 to each side, an additional 2.2, and then finally an additional 0.1 just in these little wings, just a little 0.1 there. So we can use all of these percentages to answer these. So what percent of the recruits are between 23 and 27? So that is from this line right here to this line right here. So you're really just adding those two together. So just 13.6 plus 40 or 34.1%. So that would be 47.7%. Once it's all labeled, it's actually just pretty easy to pull the data right off of that graph. What's the probability that a recruit is at least 31 years old? Okay, so that is just this portion of the graph, so not very much of it, just 2.2 plus 0.1. So that is just 2.3%. And approximately how many recruits are at most 29 years old? So two options. You can either add all of these together, or you could subtract all of these from 1. So that's actually, that would be quicker. So these 13.6 plus 2.2, that's 15.8, plus 0.1 is 15.9. Oh, how many recruits? Sorry. How many of them? So that is 32. So we've got 13.9 of them, which is, if we do, be 86.1% of, so this is 13.9, so when you subtract that from 100, that means 86.1 is all of this right here, at most 29 years old. So we want 86.1% of the 32 recruits. That way you can figure out how many, not just what percentage. So that would be, you take 32 and about 86.1% of that. So round up, you can't have portions of people. So we would have about 28 of them. Okay, let's look at the next page, which is our last page, just finishing off this topic. So number 35, the blood pressure of a group of adults is normally distributed. So we're working on to our z-scores here now. Normally distributed with a mean of 122, a standard deviation of 13. Mean is blood pressure is 108. Find her z-score. So z-score is the value in question minus the mean and then divided by the standard deviation. Because the z-score just represents how many standard deviations you are away from the mean. Negative means below the mean. Positive means above the mean. So this is, we have a negative 14 divided by 13, which is about negative 1.08. So remember with these, you always do 2 digits because you've got the z-score table that only goes to the hundredths digit anyway. Number 36, the daily balance of a checking account over the course of a month is normally distributed with a standard deviation of 84.1, $84.10. If the balance in the account on a particular day, so this is one value, this is like the x value, and then we want to find the mean. So the z-score is negative 2.4. This is the x value minus the mean, and then divided by the standard deviation. Okay, so we can use that formula to solve for a missing piece of the formula. So multiply both sides by the 84.10. Okay, so then on the left we'd have negative 201.84 equals the numerator on the right-hand side here. So I'm going to get this by itself by subtracting the 3.17 and 34 cents. So I have a negative 519.18 equals negative mu, so that's the mean. So you just divide both sides by a -1. So divide both sides by a -1, and this is just a positive value. And it is money, so include your $sign. All right, next, number 7, the length of a certain fish species is normally distributed with a mean of 15. If a fish is 18.8 centimeters with a z-score of 1.9, what is the standard deviation? So same exact formula. This time we know the z, we know the x, we know the mean, we do not know the standard deviation. Okay, so that's what we're solving for here. So this, I would cross multiply this over, so multiply. So we have 1.9 times the standard deviation. Subtract this, we get 3.8. And then you can divide both sides by 1.9. So 3.8 divided by 1.9 comes out to a nice, neat 2. Okay, so our standard deviation comes out to be 2. All right, one more z-score here. So the number of visits to the gym each year is normally distributed. Here's our mean. Here's our standard deviation. If Kurt's z-score is -1.8 and Mindy's z-score is 2.4, how many more times did Mindy visit the gym than Kurt? So basically you're solving for x for each one of them, and then you want to find the difference between those two values. All right, so let's start with Kurt. So -1.8 equals x. We'll use a k for Kurt. Minus the mean over the standard deviation. So this one we would multiply the 25 to both sides. So -1.8 times 25. So we get -45 equals Kurt's visits minus 97. So then you could add 97 to both sides of the equation. So add 97. So we get 52. So Kurt visited the gym 52 times. Once a week. Not bad, Kurt. Mindy's was 2.4, so we do this exact same setup, except this time we want Mindy's gym visits. Looks like she was above the average since her z-score was positive. So multiply both sides by 25, so 2.4 multiplied by 25. We get 60 equals m minus 97. So she was this many visits above the mean, whereas Kurt was this many visits below the mean. So then to get m by itself, add 97 to both sides. So for m, we get 157. So that is about 3 times a week. Way to go, Mindy. All right, so subtract 157 minus 52, and we end up with 105. Okay, so 105. Make sure you're always answering the question the way that it's asked. So here we wanted how many more times, which was 105. All right, a few more here. So shoe sizes of 36 students, normally distributed with a mean of 8.5 and a standard deviation of 1.5. So with this one, we're using the z-score table to figure out what values are in between these certain setups that we give. What percentage of students have a shoe size between 7 and 11? So we can figure out each of the z-scores, and then you want to figure out what's in between them. All right, so 7, let's find that z-score. So 7 minus the mean divided by the standard deviation. So this is a -1.5 divided by positive 1.5. So that's a z-score of -1. And then 11, so 11 minus the mean over the standard deviation. So this we've got 3.5 divided by 1.5. And that would be, 2.5 divided by 1.5 would be 1.67. Okay, so you want to know what's in between. So I'm going to pull up a z-table like we were using the other day. Okay, I might just have to look up a new one. Okay, so we've got a z-table pulled up here. So from -1, remember what this gives you is the value to the left. So what you want to figure out is what's to the left of 1.67 minus what's to the left of 1. Okay, so this one is the positives. So here's the 1.6 row, and then 1.67 would be here. So 0.9525. So that's to the left. So 0.9525. That's everything to the left of 1.67, but then minus, you want to subtract what's to the left of -1. So -1 is 0.1587. So you end up just with what's in between. So we can calculate that. So 0.9525 minus 0.1587. So this gives us 0.7938. So that would be 79.38%. So most, you could say. Number 40, what is the probability that a student will have a maximum shoe size of 9.5? Okay, so anything less than that is basically what you're looking at. So let's find that z-score first. The value minus the mean divided by the standard deviation. So 1 divided by 1.5 is a z-score of 0.67. So a maximum of 9.5, that would be any z-score less than this one. So lucky for us, that's the way the table is naturally set up. So anything less than 0.67. So here is your 0.6 row. We want to go all the way across to the 0.7. So that is 0.7486. So that is 74.86%. All right, 2 more from the z-table. 41, approximately how many students wear at least a size 6? So we're going to have to use the z-table in reverse here. So size 6 minus the mean over the standard deviation. So this is actually just the other direction for this one. So this is a negative 2.5 over 1.5, so that's negative 1.67. So with this one, we do 1 minus, because this we want at least a size 6, so we want to the right of the z-score, but the table automatically gives us the left, so we just have to subtract. So to the left of 1.67, okay, so here's the 0.7, so 1.6, so that's this value right here, 0.0475. Okay, so 4.75% wear less than a size 6, so more than a size 6 would be 95.25%. So just subtracting from 100%. And then 42, in between two values, how many students wear a shoe size between 8 and 10? So find each z-score, and then we'll figure out what's in between. So 8, the value, minus the mean over the standard deviation. So this is a negative 0.5 a negative 0.5 divided by a positive 1.5. So that's negative 0.33. That's the first z-score. 10 is above the mean by exactly 1 standard deviation. Okay, so in between means you want to know what's to the left of this all the way to the end minus what's to the left of this. And then that ends up giving us exactly what's in between. So I'm already on the negative one. So let's do the 0.33. So 0.30123. So 0.3707. So something minus 0.3707. So that's the probability that it's less than a size 8. So let's get less than a size 10. Okay, so there's 1.0, so 0.8413. Okay, so this is the probability that it's less than a size 10. This is the probability that it's less than a size 8. So subtracting these would give us the value in between. All right, so 0.8413 minus 0.3703, and we get 0.471 or 47.1%.